This is the video lesson for collisions. The learning target for this lesson is I am learning to define elastic and inelastic collisions and to identify them from their characteristics. The success criteria for this lesson are I can define elastic and inelastic collisions, I can identify different collision types, and I can predict collision outcomes from initial conditions. Alright, so let's start looking at collisions. So there are two main types of collisions. One is an elastic collision, and the second is an inelastic collision. So the different types of collisions are based on whether or not kinetic energy is conserved or not. So whether or not kinetic energy is the same before and after the collision. So that's what conserved means. So is the kinetic energy the same before or after the collision? That is what determines whether the collision is an elastic or an inelastic collision. Momentum is conserved in both types of collisions. So the momentum of the system is conserved in either type of collision. So the momentum of the system is the same before and after the collision in both elastic and inelastic collisions. All right, let's talk about elastic collisions. So in elastic collisions, both momentum and kinetic energy are conserved. So they stay the same before and after the collision. So in a perfect elastic collision, that means both momentum and kinetic energy are perfectly conserved. And those happen only in rare occasions, like when two atoms bump into each other, or when two charged particles, like you have an electron and another electron, those bump into each other, or when gas molecules are moving around in the atmosphere. In the macro world, meaning in the real world, the world that we inhabit, the world of things at a normal scale, there are almost no cases of perfect elastic collisions. And the reason that is because there's always a loss of energy due to things like sound and heat. So when things clack against each other like billiard balls, they make a sound, and that sound is a loss of energy. Or when things like when two cars get into an accident, there's a sound that they make, or there's heat generated when they get into an accident. All of those things are losses of energy, and that loss of energy is that loss of kinetic energy. So kinetic energy is not being conserved in that situation, so it is not a perfect elastic collision. We'll often use the formula for elastic collisions, even though the collision itself is not perfectly elastic. We'll use it as an approximation of an elastic collision, however, just for our purposes. All right, let's talk about the other type of collisions, which are inelastic collisions. So in an inelastic collision, only momentum is conserved. Kinetic energy is not conserved in an inelastic collision. So in some inelastic collisions, the objects that collide are sticking together to become one object. This happens in things like terrible car wrecks, or in a bullet fired into a block of wood. So in a car wreck, the two cars are mangled together so that after the wreck, the two cars can't be separated anymore. And so they move together as one object. Or when the bullet is fired into a block of wood, the bullet gets embedded in the block of wood. And so the block of wood and bullet move together as one thing. So technically, any collision that is not elastic is considered inelastic because energy is not conserved. So for our purposes in this class, though, we're generally going to consider an inelastic collision is something where the two objects stick together. So we have a cart, it's moving this way, and it collides with another cart, If those two carts stick together and become one cart as a mass, one cart together, that was what we would consider an inelastic collision. When the two carts bump into each other and move off in their own separate directions, that is what we will consider an inelastic or an elastic collision, even though they're not perfectly elastic collisions. So some examples of elastic collisions in the microscopic world. We have atomic particles, so electrons, protons, any charged particles that will bounce against each other and go off in opposite directions. So any charged particles that are the same charge, they'll bounce into each other and move off in the opposite directions. In the macroscopic world, so in the world that we inhabit, pool balls are good examples. So a cue ball gets knocked into, say, an 8-ball. The 8-ball goes off in another direction. The cue ball stays where it was. That's a good example. Some car accidents are good examples of elastic collisions. One car hits another car. The first car changes directions and the second car goes off in the opposite direction. Those are all decent examples of elastic collisions. So none of these macroscopic world examples are perfect elastic collisions, but they're all good approximations. For examples of inelastic collisions, we've got really bad car wrecks, where the two cars get stuck together. So they get mangled together so that there's only one car after the wreck. Terrible drawings of cars. So the two cars before the wreck act as they're separate cars, and then after the wreck, they both move in the same direction because they're stuck together. If you fire a bullet into a block of wood, I used this example earlier, the wood itself has the bullet lodged inside of it. So this is one object after the bullet lodges inside the block of wood. A tackle in football. Where the players both fall down onto the ground. So you have one player tackling another player, and they both end up on the ground together. So you have both players on the ground. When they are moving together onto the ground, so as they move together onto the ground, that is a good example of an inelastic collision. So this motion from when they hit each other until they hit the ground, that is a good example of an inelastic collision. All right, everybody, keep asking questions. It's how you learn new things.